So when somebody talks about being precise, okay, somebody with a hand, give me a definition or a synonym for precise. What does it mean to be precise? When I say precise, yeah, Trevor.
You like 100% perfect?
Perfect. Okay, what's something else? Exact, close to, correct, right? These are all things we talk about precise. In geometry, we talk about precision or precise in terms of measurement. We're precise to this amount. We're close enough to this amount. Okay, and we're going to talk about how to find precision. Okay, so this is the next chapter. We determine the accuracy of a measurement, and we compute with measures. Basically, if you know how to use a ruler, you will know a lot of this section. Okay, the couple vocab terms here. A line segment. We had briefly talked about that. A line segment has two endpoints. Okay, it has a beginning and an end. It can be measured. You can measure a line segment. You cannot measure a line. Why can't you measure a line? Because it goes on forever. Exactly. Okay? You don't have to. If you think the definitions make sense, okay? If you'd like to, you're obviously welcome to. Line segment has two endpoints, has 2 points that we call line segment AB, for example. Precision, now this might not make sense until we actually do some problems with this, but precision depends on the smallest unit of a measuring tool, and we're always precise within half a unit. For example, you guys know when you use a ruler and you look at the inch side and it has 1 inch, 2 inch, 3 inch, what's like the next tick mark under an inch usually? Like the next biggest one. You know, a half of an inch, and usually under half of an inch there's a smaller one, which would be a fourth of an inch, a quarter of an inch, and then under a quarter of an inch sometimes there's an eighth of an inch, and then under an eighth of an inch sometimes there's 16th. And then if you had this really precise ruler or this really good ruler, you might have 1/32 of an inch. Okay? So we're going to talk about the smallest measurement on a ruler. That's going to help us determine precision. Betweenness of points. This is a complicated way of saying you can have a point that's between two other points. Okay? If you have 3 collinear points on the line, one of them is between the other 2. That's just the math definition or the book definition for betweenness of points. Okay? We talk about things between other points. It's just in the middle of them. Okay? It's not necessarily directly in the middle, but it's between them. So this is the next section called linear measurement and precision. Okay? We're going to measure things and determine, are we precise, or how close are we precise? Okay? Or how precise are we, I guess is a better way to say that. Okay? Again, those last 2 definitions might not make a ton of sense until we get into some examples of those. Questions at this point? Precision and betweenness of points. The other things we have is between. Okay? Well, we all pretty much know what the word between means. Okay? If I have a line, there's a line, and I have A, B, and C. B is between A and C, right? And if I said, for example, if I said AB is 1 inch and BC is 2 inches, how long would it be from A to C? 3 inches. Crazy, right? Okay. That's what between means. If you have one little piece plus another piece, it's equal to the entire piece. Yes?
Why does it say QIFF?
Good question. Very good question. IFF. We haven't seen that notation before. It says point M is between points P and Q. So instead of using A, B, and C, how about I draw a picture of P, Q, and F? So point M is between P and Q. IFF means if and only if. It's a short way to, instead of writing if and only if, it's just IFF. If and only if P, Q, and M are collinear, which they are in my figure, and if you add whatever PM is plus MQ, it's equal to the whole thing. Okay? Point M's between those, so if you add this little piece, which say I called it 1 inch, and add this little piece, which I called maybe 3 inches, the whole thing would be 4 inches. Okay, IFF means if and only if. Good, great question. Congruent. We're going to talk about congruent for the rest of the year. Some of you may have heard that before.
How is it 4 inches?
Just because if you add this segment, which is 1 inch, and this segment, which is 3 inches, the whole thing would be 4 inches, right? See what I'm saying with that? So on congruent, It means segments are the same measure. Now, there's going to be a difference between congruent and equal. We'll talk about that difference pretty soon. Congruent basically means two lines or two line segments are clones of each other. They're the exact same. If you took one and laid it on top of the other, it would match up perfectly. Okay? Congruents are things of the same measure, and we use this symbol for congruent, an equal sign with the little squiggly on top. Isn't English people that know it better than me, that's called a tilde? Is that right? Anybody heard that?
It's a tilde.
Isn't it a tilde? That's what I've heard. And honestly, I couldn't tell you what else it's used for besides some Spanish, because I'm not very good at that. I wish I was better. Anyway, that's congruent, an equal sign with a tilde on top of it. Okay? That means congruent. That does not mean equal. That means congruent. So two segments that have the same measure are congruent. You also see in your book, these, I call these little pink tick marks. See, it has a little just dash through it. That means those two pieces are the same, or those two pieces are congruent. So when you see in your book they have a little pink tick mark in them, that means they're congruent. They're the same. Okay? And then last, the definition of construction, which is what we just did. It's methods of creating figures without measuring tools. So without a ruler, without a measuring tape. Okay? We created those figures only with a straight edge and with a compass. That's what a construction is. We'll have lots of constructions in here. We just did the first one, which was copying a segment. So we're going to talk about congruent. What's the difference between congruent and equal? And notice when it talked about these two pieces, it didn't put the arrows on the end. It just put the bar on top. That means segment XY, segment PQ. Okay? If it put the arrows on it, then it would mean line XY, line PQ. But without the arrows, it's just a segment. Okay. Questions? Yeah? So, using a ruler, this ruler is centimeters. Okay? I want to find what is the length of line segment LM. It's a line segment because it has two endpoints. Okay? Well, since this says centimeters, all these bolded lines are centimeters. What are these little lines underneath?
Fractions of centimeters.
They're fractions of centimeters. What specifically fraction of centimeters are they? Millimeters, right? The next thing under centimeters is millimeters. Okay? How many millimeters make a centimeter? 10, right? Because if you counted this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 1 centimeter. 20, 2 centimeters. 30, 3 centimeters. Okay? So if you were to measure this line segment, let's say we wanted to measure it in millimeters first. How many millimeters is that line segment? It's 42, right? Because if you were to count all those little tick marks, which I wouldn't because that would take forever, I know this is 40, and it looks like two more, 42. Now let's say I wanted to measure it in centimeters. It's 4 and some change, right? It's 4 and a little bit more. 4, and that's 2 out of 10 centimeters, right? Or millimeters. 4.2, 2/10. So it's also 4.2 centimeters. Those are the same things. The reason I got 0.2, because it's 0.1, 0.2, 0.3, 4, 5, 6, 7, 8, 9, and then it's 5. And then it's 5.1, 5.2. That's because every 10 millimeters makes a centimeter. Right? So this one didn't tell you measure it in millimeters or centimeters, but we could do both. Okay? The smallest unit on this ruler is a millimeter. Right? There's nothing under a millimeter on here. What is under a millimeter? I forget already. Don't you guys do that in science class? We should do it here.
No.
It's like deca and giga are all top, or mega, you know. Nano is really small. I don't know. Nano's the smallest, isn't it?
No idea.
I forgot off the top of my head. Anyway, rulers are only 4 millimeters. Okay? Yeah. That's not for us. So, if you were to measure this line on this ruler, it only goes to centimeters, so we would call that 5 centimeters. Okay, right? That's the smallest unit of measurement is a centimeter there. Find the length of AB. This is in millimeters. Think about this one. Just in millimeters, how many millimeters is this? 18, right? Because you got 10 to here, 15 to here, another 3 or so would be about 18. Okay. Well, this is pretty straightforward. Only in centimeters, so this would be 2 centimeters. Okay. Now, this is in customary units, also known as standard units. United States is really one of the only countries that use standard units. I don't know why. Okay, that's things like inches and feet and yards. Okay, so this ruler's in inches. We know all of these are 1 inch, 2 inch, 3 inch. Okay, what are the second biggest tick marks here? The next biggest one is half of an inch, right? 1 out of 2 inches, 2 out of 2 inches. Okay, half, 2, half, 2. What's the one under half? A quarter of an inch. Okay. Yeah, on the ruler, only one side will be inches and fraction of an inches. The other side will be centimeters and millimeters. Okay. Quarter of an inch, 1 quarter, 2 quarters, which 2 quarters is also 1/2. 3 quarters, 4 quarters, or 4 out of 4. 4 out of 4 is also 1. Okay. So that's what those little tick marks are, 1/4 of an inch. So how many inches would we say this line segment is? Well, it goes to 2, 1 quarter, 2 quarters, 3 quarters. So we could say 2 3/4 of an inch, or we could also say, if we wanted to put that in decimal, what would we put it as a decimal?
2.75.
2.75. Okay. You can either stay here or go in the hallway. 2.75. If you wanted to put it in decimals, I'd rather leave it in fractions. Okay. To me, fractions are easier to work with. The only time I use decimals most often is money. Okay? Think of it this way: like you can think of fractions as like watching a KU basketball game. It's simple, it's fun, you know, and decimals are like watching a K-State basketball game. It makes you want to like poke your eyes out. You don't like dealing with it. It's just a hassle. Okay, something like that, right? So think of it that way. Use fractions most of the time unless it's money. Okay. So find the length of AZ. Yes, question. So this is in inches. I want to measure this in inches. I want you to think about this for yourself for just 20 seconds or so and think of what the answer is, and then we'll wait just a second. Yeah, Dallas?
I say it's D, 1.5 inches.
It is 1.5 inches, right? 1 inch, 2 inch, this is a half. We know these lines are a quarter, okay? Well, if these lines are a quarter, okay, the next biggest lines are probably what? An eighth, and the ones under that are a 16th. Now, if you don't know for sure, what's one way you could find out if you don't know if that's a 16th or if you don't know if that's a 32nd? What's one way you could find out? Yeah.
Go from halves and work down.
Go from halves and work down. Or if you really wanted to, you could sit here and count them. 1, 2, 3, 4, 5, 6, 7, 8. Well, you know 8, and you get to halfway, well, that would be 8 out of 16. If you wanted to keep going, you would get 16 out of 16, which would be the next inch. Okay? These X. Length of IX. Now, this is in inches. Okay? But the ruler is less precise. The ruler has less measurements underneath it. Okay? So what would be the measurement of this line segment? What? It would be C, 2 1/4 of an inch. Because the smallest unit of measurement on this ruler is 1/4 of an inch. It's very important that you're able to identify that when we talk about precision. When I give you a ruler and I say, what's the smallest unit of measurement, you're going to see what the smallest tick mark is and say, well, that's 1/4 of an inch. Okay? Because in precision, we talked about things being precise within 1/2 of the smallest unit of measurement. What that means, when I say find the precision, we're going to practice this a lot. We won't get through all of this today. Find the precision for 32 3/4 inches. Okay? Which that means if they had a ruler that was this long, what was the smallest unit that they measured in? Yeah, 1/4 of an inch, right? 1/4 of an inch. This ruler had 1/4 of an inches on it. So you're going to take that 1/4, whatever the smallest unit is, and you always multiply by 1/2. You take whatever the smallest unit is and multiply by 1/2. So they took 1/4, because that's how small this ruler was, and they multiplied by 1/2. And we know when you multiply fractions, you just multiply the numerators, you multiply the denominators, and get 1/8. Okay? So this measurement is precise to within 1/8 of an inch. Okay? That's what we determine precision by. It's precise to within 1/8 of an inch. Okay? You're going to be asked to decide what the precision is. It's always half of the smallest unit of measurement. So it also says the measurement could be 32 5/8 or 32 7/8. How did they come up with those numbers given that the precision is 1/8 of an inch? What the heck does that mean? Okay. How did they come up with those numbers given that the precision is 1/8 of an inch? Okay. Well, our original measurement, let me clear out some space here. I'm going to make some writing space here. So our original measurement was 32 3/4 of an inch, right? And we said the precision of this measurement is always half of the smallest unit, which we found to be 1/8 an inch. What happens if you take 32 3/4 and subtract 1/8 of an inch? You get 32 5/8. What happens when you take 32 3/4 and you add 1/8 of an inch? You get 32 7/8. That's how they determine the measurement could be in between here, because it's precise to 1/8 of an inch. For those of us that forgot how to do that, if I take 32 1/4 and I add 1/8, okay, all I need to do is add these two fractions together. Well, you need common denominators. Common denominator between 4 and 8 is 8. So you have to multiply this by 2 over 2. And you get 6/8. Oops, wrong thing. Six-eighths plus 1/8 is 7/8. That's how they got that. If you take 32 6/8, subtract 1/8, you get this. So when we talk about precision, you take the smallest unit, multiply by 1/2, that's the precision. The measurement could be between whatever that precision is plus the original measurement and whatever that precision is, the original measurement minus that original. Let's do a couple more examples, see if that makes sense. Find the precision for 15 millimeters. So the first thing we always want to do, what's the smallest unit of measurement they used? So on this ruler, what's the smallest piece they used? Millimeters. They used 1 millimeter, right? That's the smallest piece they use. So when you are asked to find precision, you're always going to take the smallest unit, which was 1 millimeter, and you always multiply by 1/2. Always. Well, 1 times 1/2 is 1/2, right? So our measurement is going to be precise within 1/2 of a millimeter. That's how we get precision. We always take the smallest unit and multiply by 1/2. So the precision is 1/2 of a millimeter for this measurement. That means the measurement could be somewhere between 14.5 millimeters and 15.5 millimeters. Because I took the original measurement and I subtracted the precision, that's how I got 14.5. And I took the original measurement and I added the precision. I got 15.5. So our original measurement is somewhere between here. We are precise within 1/2 of a millimeter, okay, given this original measurement. All right, let's look at another one. I want you to try this one yourself. I want you to find the precision for 88 millimeters and then tell me within how many millimeters is this measurement precise, from what to what. Okay, this one's very similar to the last one we just did, actually. What is the precision for 88 millimeters, and it's precise from what measurement to what measurement? I'll give you a minute or two to think about that. The first step in all of these is finding out what is the precision. So you look at what's the smallest unit they used. Did they use 1/4 inch, 1/2 inch, millimeter, centimeter, 1/8 of an inch, 1/16 of an inch? What's the smallest unit they used? Millimeter, okay? They used 1 millimeter. That's what their ruler used. You always take that smallest unit and you multiply by what? 1/2, always. Well, what's 1 times 1/2? 1/2. So we are precise within 1/2 of a millimeter. That means our actual measurement is going to be somewhere 88 minus 1/2 millimeters and 88 plus 1/2. millimeters. Well, if you take 88 minus a half, 87.5 to 88.5. Okay. See how that works? Yes.
So it just has to be, it could be like centimeters and you're still multiplying by half.
Yep, it's always by half. Now, I kind of got confusing because I used a fraction here and I used a decimal here. Hopefully that's not confusing anybody, right? 1/2 is the same as 0.5. Okay? So I was kind of jumping back and forth. I went against my own rule of using fractions. How about this one? This one's a little tricky. Okay? So, find the precision for 7 5/8 millimeters. So you want to first figure out what's the smallest unit they used and multiply that fraction by a half. So I'll give you a second to try this one. This one's a little different than the other ones. What's the smallest unit they used, like if you were looking at their ruler, and you multiply that by a half. Now, it's not the actual measurement, it's the smallest unit on the ruler. So their ruler went to how much of a millimeter? It went to eighth, right? It went to eighth of a millimeter. Because that's the denominator here. I know on their ruler they could measure to the eighths. Okay? So I'm going to take 1/8 and multiply that by a half. I don't take 5/8. I take the smallest measurement they used, which was eighths of a millimeter. Yes, question.
Would that be 16th?
It would be 1/16, right? So the precision for this measurement would be 1/16 of a millimeter. And then what you would do, okay, that's the precision. If the question asks, find the precision, you just stop right there, which is what we did. That measurement is precise within 1/16 of an inch. Or sorry, 1/16 of a millimeter, not an inch. I apologize. 1/16 of a millimeter. Okay? A millimeter. I knew they used 1/8 because I saw the denominator was eighth. They measured in eighths. They measured 5/8. Okay? I take the smallest measurement and I multiply by half. Okay? The last part of this section is just finding pieces of a line segment. Remember we talked about point M being between L and N? So if the whole thing is 4 centimeters, and from here to here is 2.6, how could I find from L to M? Just subtract them, right? I know the whole thing's 4, and from here to here is 2.6, so I'm trying to find out what is this piece right here. Okay. Well, if I take the whole thing, 4, and subtract 2.6, we have to add 0.0 here. I'll need to borrow 1.4 in my units in centimeters. That's that piece right there. Because if you add 1.4 and 2.6, you get 4. This is what we talk about when we say between. Point M is between L and N. Okay. Let's look at the next one. Yeah, that's what that all says. In this line segment, okay, I give you what XY is, and I give you what YZ is. The question is to find out what's the entire segment from X to Z. I give you this chunk, and I give you this chunk. So how would we find the entire thing? We would just add those together, right? We take 4 5/8, and we add 2 1/2. Okay. Now again, we need common denominators here. So between 2 and 8, a common denominator would be 8. So if I multiply that by 4 over 4, 2 5/8 plus 2 4/8, okay, would give me 6 9/8. Right. Remember, this is greater than 1. Okay, this is greater than 1. So I'm going to take 8/8 away from this and make the whole number. And I'm left with 7 1/8 of an inch. That entire line segment is 7 1/8 of an inch long. Okay? All I did was I added those two chunks of it together. Okay? Questions on the adding or subtracting or adding fractions part? I know it's probably been a while since someone's done that. Okay. Now, I would like you guys to write this one down because this is a prime quiz test question. And attempt it first by yourself. This one's a little tricky. So go ahead and draw out the figure. Just sketch it off to the side. And try and find x first. Okay. So I'll give you 3 or 4 minutes to try this one. This might be the last one we get to today. I want you to think about it yourself first before we go over it. They labeled ST for us as 7x. SU is 45. That's not labeled in this picture. From U to S or from S to U, it's the same thing, is 45. So I'm going to go ahead and label that. From here to here is 45. It didn't tell me inches or feet or anything yet, so I'll just leave it at that. And then the other piece of information it told me is TU, this piece, is 5x minus 3. So let me give you another problem. What if this piece right here, from here to here, was 40? How much would this piece be? It'd be 5, right? I know these two pieces added together equal 45. So instead of giving me numbers, they just gave me variables. But if I add them together, they will still equal 45. So if I take 5x minus 3, I'll write in a different color here. If I take that first piece, 5x minus 3, and I add it to that second piece, I know that is going to equal what? 45. Okay. So now we're solving multi-step equations. It might have been a while since we've done this. Remember, the first thing we always want to do is get like terms together. I like to underline my like terms the same. For example, 5x plus 7x is going to be how many x's? 12x, right? Okay. And our goal here is we're trying to get the x by itself, so we have to undo addition or subtraction first. So how do I move the minus 3 over? Add it. Oops. Equals 48. And finally, how do you get the 12 by itself? So the first part of the question is answered. It says find x. We have found x. The second part of the question, though, says how long is ST? How long is from here to here? Well, I know it's 7x, but I know what x is equal to now. So how long is ST? 28. I would just take 7 times 4, and ST is 28. So this one might have threw us just because it used variables instead of numbers. It's still the same process. This chunk plus this chunk is equal to the whole thing. Okay. Now let's look at this one. This one says find SE from here to here. Who can tell me what these double tick marks mean? Yeah, it means point E is exactly in the middle of SG because these two pieces are the same. I know this green piece is the same as this red piece because of those tick marks. That's what those tick marks tell me. So I know the whole thing is 4 5/8. So if I take half of that whole thing, it would be each of those pieces, right? And to take half, I just take 4 5/8, and I want to take half of it. Remember, of means multiplication. So half of 4 5/8. Okay. Now I do need to make this a mixed number. Let's do that because we haven't done that yet. 4 times 8, 32, plus 5, 37. 8 times a half gives you 37/16. Now remember to go back to you see how many times does 16 go into 37? 2. That gives you 32. There's 5 left over, right? And then you keep the same denominator. So each of those pieces are 2 5/16 inches long. If I was to add 2 5/16 plus 2 5/16, I would get 4 5/8 once I simplified it. I don't have to go back to 8s, no, because this can't be simplified anymore. Right. Okay? Other questions on this one? So that tested to see that you know what those tick marks means. Those tick marks means those pieces are congruent. They are the same measure. Okay? We're going to look at one more before we put up today. I want you to find ON yourself here. Last one today. So the whole thing is 4.2. From N to E is 0.5. So ON is whatever that is subtracted.